Jedi of Believe, and you're here in the office of the Always Believe House. Oh, today we are gonna set a magical time because we're gonna learn about linear regressions. What's a linear regression, you ask? It's how you use the TI calculator to enter data to calculate a line of best fit. And with it, you can use it to estimate. So we're about to get started, and this is going to be F-U-N, fun, fun, fun. So a magical whiteboard appears, and let's start rocking and rolling. Okay, the first thing we're going to do is they give you a plot right here, the age and the growth, right? Notice that these dots almost make a straight line, don't they? Not all the dots would be on the line. You would draw a line of best fit. In 8th grade, I think y'all did this before, lockdown last year, but in 8th grade, you make these scatter plots. This would have a positive correlation with it because the line is going up with it, okay? And these dots are pretty close to the line. So using the calculator, we're going to calculate the line of best fit, and then we can estimate with this. Now then, if you think about this, you're not going to keep growing linearly, right? Once you get about 14, 15, 16, you stop growing. So your growth goes up and then it levels off, okay? So you wouldn't keep growing forever and ever and ever, okay? But anyway, what we're going to do is we're going to learn how to put these numbers into the calculator. Now then, if you look at the calculator, your X is the age in years and your Y is the height. So the height depends on the age, right? Okay, so get your calculator, and we are about to start rocking and rolling. Okay, so I'm going to clear my calculator, so I'm going to hit Menu 1, and then Clear History 5. So I got my scratch pad. I'm just going to use the scratch pad here. So you hit the Home button, go to Calculator. First off, hit the Home button. Now then, we're going to create a table and put this table in it. If you watched the star review today, we did this on the star review. Going to do the same thing. So hit the Home button and then click New. Every single time you do this, you do not want to save the document. So click No. And then we're going to add a list in a spreadsheet, which is 4. And then what you do automatically every time is you hit the Up button and go to where it says A, type in X. And let me hit Control Caps and then Enter. And then go over there to the B and hit Y and then Enter. Now then, you automatically do that. Do y'all see these 2 gray sections? Never ever hit Enter or do anything in those sections because it makes an equation. Hit the down button and you want to go to where it's A1. Now then, we're going to start typing in the X's. And this is going to be kind of hard for me because I can't see the table, but it's 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are our X's. So 2, enter, 3, enter, 4, enter, 5, enter, 6, enter, 7, enter, 8, enter, 9, enter, 10. If you miss up on this, it's going to make an error in your data. Now then, you got to hit the over button and then go up all the way to the first column in the B, okay, first row B. So I'm in first row, and now I'm in B. I'm going to type in my B's, which is 34, 37, 40. 34, enter. 37, enter. 40, enter. I'm going to go back. And then I got 42, 45, 48. 42, enter. 45, enter. 48, enter. And then I have 2 more, 50, 52, 54. 50, 52, 54. So 50, enter. 52, enter. 54, enter. Make sure your table is correct. I'm not going to go through and check it. If it's wrong, you're going to get the wrong data. Also notice that the blue square is not on the 54. If it's on the 54, none of this works. You have to hit enter. Okay? So the blue square's got to be below your last data field. Okay? Now then, we're going to run a stack calculation. And you write this down, so you're going to repeat the process. We're going to do this a lot today. So you're going to hit Menu, And we want to run statistics, a stat calculation 4, and then we're going to run stat calculation 1, and we want to call what's a linear regression. A linear regression is 3, and notice it's mx plus b. What this is going to do is calculate the m, the slope, and the b, the y-intercept. It's going to give us decimals, not fractions though. Okay, so hit 3 for a linear regression. Now then, the x list is going to be the A column, and remember we typed in x. In the B column we typed in y. So do this every single time. X down, y down, and then hit enter. And bam, I got this down. Now then, I'm going to scroll up, and I'm going to tell you what these mean. Okay, so I'm up at row 1. So title, linear regression, and then on the next row, it says regular equation is mx plus b, and where I have my blue square, that is the slope, which is 2.51. That means you're growing 2.51 feet every year, and the b is 29.56. We're going to round this to the hundredth, so 29.57. That's the starting height, or that's year 0 for the height. That's your starting number, or the y-intercept. And then lastly, the correlation coefficient is not r squared, it's r, and it's 0.997. The closer that is to 1.00, the closer the dots are to the line. This is a very, very strong linear correlation. All the dots are really close to the line, as we saw in that line of best fit. If the dots were spread out, that r would approach 0. If there's no correlation, it would be 0. And you wouldn't be able to calculate the line of best fit because the dots are all spread out. Now then, let's go back to the calculator. So 2.52, I'm going to use this and round it to the hundredth. Okay, so I'm going to put m equals 2.52 and b equals 29.57. Okay, now then I'm going to go over on the page. And notice, this is what they got calculated here. They got 2.5 and 60, right? Okay, so the equation is going to be y equals 2.5 2x plus, and then 29.57. Now then, notice, this is how they did this by hand. So they went through, they picked 2 dots. They picked these 2 dots. They found the slope, they used point slope, they made it mx plus b, and then for a 12-year-old, they put in 12. What we would do is we would type this in and do 2.52 times 12 plus 29.57, and that would be the estimate with the calculator, okay? Oh, a lot of stuff. This equation you just got right here is a lot easier than doing all this. That takes time, okay? So the calculator is kind of tedious to put in, but it's very efficient, and it gives you the exact slope and y-intercept of that line of best fit. Now then, let's go to the next one. Okay, so we're throwing darts real quickly. Let's just make a quick T-chart. This will be the distance will be x, the number of hits will be enter, so this will be bullseye. And notice the biggest number is 10, 9, 8, 7, 6, 5, 4, 3, 2. Okay? And then it's going to go from 2 to 15 feet. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And this will be feet. Okay? So at 2 feet, he gets 10 bullseyes. Then at 5 feet, 3, 4, 5, he gets 9 bullseyes. Then at 7 feet, 7, he gets 8 bullseyes. At 8 feet, he gets 6 bullseyes. At 10 feet, he gets, right here, he gets 5 bullseyes. At 12 feet, he gets 1. And at 15 feet, he gets 2. So the line of best fit would be doing this, wouldn't it? It would be going down, wouldn't it? This would also be a negative correlation, okay? It's a negative correlation because the dots are going down. As x increases, y decreases, right? Now then, we drew the trend line, Now then, we're going to do the equation, and we're going to run the calculator. So on the calculator, we're going to write down what M is and what B is, and then put that into the calculator, okay? So let's go to the calculator, and we want to get a new table. So hit Home, click 1 for New. You don't want to save this, so click No. And then we want to create a list for, and then remember, X and Y on the top. So up, X, enter. Right arrow button up, Y, enter. Then hit down and left. So I have my X and Y at the top. Now that I'm going to start putting in my data. Okay, so 2, 5, 7, 8, 10. 2, 5, 7, 8, 10. And then I need 12, 15. 12, 15. Make sure the data is correct, okay? I can't go back and check it because it'll just take too much time. I need to hit the up button and go to row 1 and B. So I'm in row 1B, and now that I'm going to start typing in my number of hits. So 10, 9, 8, 6, 5. 10, enter, 9, enter, 8, enter, 6, enter, 5, enter, and then 1, 2. 1, enter, 2, enter. Now then, make sure that blue box is below all of your data fields, okay? Now then, we're going to run a linear regression. You might want to write notes on this. So we're going to hit Menu, Statistics is 4. We're going to run a stack calculation, which is 1. And then we want to run a linear regression 3. And then X down, Y down, enter. X down, Y down, enter. And bam, okay? Now then, if I were to scroll to the top, this is the linear regression and this is my slope. Remember, the slope should be negative because the dots are going down. Negative 0.74. We're going to round to the 100th, okay? Negative 0.74. So my M is equal to negative 0.74. And my Y-intercept was 12.13. I'm going to round the 2 up. 12.13. That is my equation. Y equals negative 0.74x plus 12.13. Now then, using this equation, I can calculate an estimate. So I want to estimate the 6 feet. So Y equals negative 0.74 parentheses 6 plus 12.13. Okay, so I'm going to go to the calculator. I'm going to go to Home. I'm going to calculate. And now that I'm going to type that in. Negative, and it's negative 0.74 times 6. Negative 0.74 parentheses 6. And then plus 12.13. Plus 12.13. So negative 0.74 times 6 feet plus 12.13, and at 6 feet, he should hit 7.7 bullseyes. If you round that up, it would be 8, right? Because he can't hit 0.7 bullseyes, right? So let's just do 7.7. So equals 7.7 bullseyes. If you rounded it to a whole number, it would be 8, wouldn't it? Because you can have a decimal for that, can you? Let's do one more stack calculation together. Okay, so first off, and then let's go back to the table. So can I get back to the table? Okay, I'm going to hit cancel. I can't get it. But anyway, the R, I forgot to look at the R. The R would be the correlation coefficient, and it should be really strong on that. Let me click document. Is a document there? No, it's not going to work. Okay, I can't get back to. Oh, there it is, right there. Okay, so let's go down to the R. And notice the R. Oh, you got to go up. Sorry about that. The R is right here. Notice that it's negative because the line goes down and it's negative 9.4. Notice this isn't as close to negative 1 as the other one. But still, negative 9.4 is a very strong correlation, and all the dots were really close to the line of best fit. If this gets below like 0.8, it starts getting weak. It has to be above 0.9 to be strong, okay? A strong correlation would be R over 0.9, and it gets weaker as it goes down, okay? The closer it gets to 0, there's no correlation. The dots are just scattered. That would be like your shoe size and your IQ. It would not form a pattern. There would be no correlation, okay? Now then, let's click Home. Let's do 1, and then we're going to create a new one, so no. And then we're going to create a list or spreadsheet, and then go up and type in X, hit enter, right arrow button up, Y, enter, and do not hit enter on these gray squares, go down. If you do, it's going to make you type in an equation. Now then, let's go to here, and we're going to type this in. Okay, so look at what it says. Run a linear regression, that's what you were just taught. Write down the equation and the correlation coefficient. Describe the type of equation. Okay, so we're going to see if it's strong or weak, okay? Now then on this one, our x's are going up, and so are our y's. This would be a positive correlation, wouldn't it? As x increases, y increases. So x is the hours, y is the tips, okay? The more hours you work, the more tips you get. That makes sense, doesn't it? Okay, so 2, 3, 6, 8, 9 are my x's. So go to your table. 2, enter, 3, enter, 6, enter, 8, enter, 9. So 2, 3, 6, 8, 9. Let me make sure that's right again. 2, 3, 6, 8, 9, that's right. I'm going to go back to the calculator and go up to that first row. So I'm at the first row. Now then I'm going to put in Y, which is the money. 36, 62, 120. 36, enter, 62, enter, 120. I would go by 3. You can remember 3 real good. You're probably looking at your paper though. And then 148, 165, 148, enter, 165, enter. I got my numbers in, right? Now we're going to do the linear regression. So menu, statistics, stack calculations, linear regression. And then when you get to here, X down, Y down, enter. X, down, Y, down, enter. And boom, I got it. My M is 18.10. So M equals 18.01. B equals 4.83. Round it to the hundredth. And that's going to give me my equation. Y equals 18.01 plus 4.83. Now then we're going to go look at the R. What does the R equal to? The R's right here, 0.996. That's extremely strong. So a strong correlation. If it gets below 0.9, then put like medium. If it's below like 0.6, put weak. Okay? So let's use weak, medium, and strong. Okay? Piece of cake, you should be able to run the rest of these on your own. Turn the page over to the back and go to this. Okay, we got to change the years. This is your X, this is your Y, but you're not going to use this for the years. The first year will be year 0. Then 2002 will be year 1. 2003 will be year 2. 2004 will be year 3. 2005 will be year 4, and then year 5 and year 6. Use those for your scatter. That's your X's, okay? If you use the actual years, it won't work because that's the year. You're not doing 2002 years. You're not going from the birth of Christ to where you got the car, okay? Okay, so year 0, when the car sold, it was 20,000. The car sold in thousands. And then as you go up, notice that the number of hybrid cars is increasing. Okay, so we're starting off year 0 at 2001. And then just answer those questions, okay? Should be able to do the rest of this on your own. On these right here, if X makes Y happen, you've had these on the star review. X makes Y happen, you circle it, right? If it does not correlate, you leave it blank, okay? Have a wonderful, wonderful day. Remember, you are amazing. You were created to do wonderful things, and you are awesome.